Hello, hi, and welcome to my stream. Today is December the 10th, and I'm going to be starting with Advent of Code. Let's switch over to my screen, and then moving on to the Rust roguelike tutorial if there's time. We got pretty far yesterday with the roguelike tutorial, but we're going to start off with Advent of Code. So let's make sure I'm all set up here. And I am. And status is clean. So I always hesitate to dive right in because I generally don't wait a long time before starting the stream after going live. But I'm going to dive right in anyway because I want to get to this. I don't know if it's going to be something that's going to take a long time or a short time. Might be hard, like the digits one was pretty hard. It took a good hour and 15 minutes to complete. Yesterday's was pretty straightforward. It only took about 40 minutes to do on stream. Streaming is always, writing code on stream is always slower than writing code on just on my own, mostly because of the talking. I don't normally talk when I code in my real day job. Okay, enough rambling. Before we do anything else, we're going to set this thing up to make sure that we can, our quick fix list is working. Get that to fail. I'm going to do the old make dir source. Next year I'm not going to do this. I'm going to do it this way. And now I'm just doing it now because consistency. Somebody once told me consistency is key. So we could just say pub fun, day 10, println, day 10. This time I remembered to hit the bang after println. That works. Does it run? It does. Okay, so I think we're ready to go with day 10. Let's get started. All right, syntax scoring. You ask the submarine, oops, I hate when I do that. Anyway, you ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error in navigation subsystem online, all of them. All of them? Okay, the damage, I don't know what this means, all of them. Oh, online, all of them. Okay, every line has a syntax error. The damage is worse than you thought. You bring up a copy of the navigation subsystem, your puzzle input. The navigation subsystem syntax is made up of several lines containing chunks. There are one or more chunks on each line, and chunks contain zero or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of 4 legal pairs of matching characters. All right. So this is a legal chunk and contains no other chunks, as is this. More complex but valid chunks are these guys. Oops. Okay, and even this. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. Okay, corrupted lines where one chunk closes with the wrong character. Okay. All right, so part 1 seems pretty straightforward, right? If we're just checking to make sure that we have a close for every open, and the open character style matches the closed character style. Not sure if style is the right word, but that's what I'm going with. So this expected a square and found a curly, which is fine. So I think I understand all of this. Stop at the first incorrect closing character on each corrupted line. Did you know that syntax checkers actually have contests to see who can get the high score for syntax error in a file? It's true. No, it's not. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. 357, 1197, and 25,137 points for each type of character. Are those all primes or something? In the above example, an illegal was found twice. Oh, up here. Okay, yeah. So we found 2 illegal those, one illegal of those, one illegal of those, and one illegal of those. And we just add them up. Find the first illegal character in each corrupted line of the navigation subsystem. What is the total syntax error score for those errors? Okay. This seems suspiciously straightforward. Let's start by creating our test input. Oops. Inputs, and we're just going to say test day 10 text. Put that in there. Right, and then I keep forgetting what the syntax is for reading a file. It's this line. No, it's not this line. Although maybe I can use a hash set to do mapping between open and close, but I'll start off just doing a match and see how that gets us, how far that gets us. All right, and then we'll read the file, and we're going to read test day 10. So let's just start off by making sure we can read the file. Do that and say lines len. Let's just run it and see what happens. So we got 10 lines. That looks like about 10 lines. Yeah, that's 10 lines. Okay. So we should now be able to just write a score function for each line, right? Oops, wrong file. Day 10, which of course is not in Git files. There it is. Okay. So if we write pub fun score and we just give it a line, and we can return a score for the line, right? We can loop over each character, line.chars, right? And then for each character, we can see what kind it is and save. We'll just put on a stack, right? We did stacks yesterday with vectors. We'll call it expect. It's a vector of chars. New, right? This is all we need to do. And then match C. If it's an open, then we're going to expect dot push to close. Like that, right? And we can do that for each of the 4. That's what I was saying, you know, with a hash set, what we could just do is, you know, if we can just say expect.push hash map, sorry, dot get the match or something like that. We don't even have to check the character, but I'm just going to do it this way. This is kind of a, this will get us there. For anything else, then it's going to be one of the close characters, and I'm going to match on that again. And the reason I'm doing it here is why. Because I want to return the score if it doesn't match. So we want to say if C is not equal to expect.pop, right? We're going to pop the last one, and it should be a closing character. Then we're going to match on C here. If we got a close and we weren't expecting a close, that one's worth 3, right? And then we have a square brackets, which is worth 57, a curly, which is worth 1197, and an angle, which is worth 25137. Anything else is just an error, right? We got an illegal character. Just like that. Oh, 1 second, please. I'm confused why this didn't. Oh, maybe because of the comma. No, it still didn't line up the match. All right. Maybe that's a Vim problem. Okay, that's pretty straightforward. And then if nothing if we go through the entire line and everything works, then we can just return a 0 as our result, right? Or everything matches, or there's still stuff left on the vector. But right now we don't care, right? It says find the first illegal character on the line and then look up in the following table, right? So we don't care if there's stuff left over, because the expect array will contain just the characters we're expecting to see in the order we're expecting to see them. And if there's some left over, we don't care. We're just going to return 0 and throw away the rest of the characters. So all we need to do now for each of the lines is equal to lines dot iter, right? We're going to iterate over each line, and then we're just going to add up for each line. We're going to say sum plus the score of the line, right? And that's all we need to do. And then println day 10 part 1 is this part 1. I'll put those lines together, and then we can do part 2 after that. So let's see if this works. Does this check? It doesn't. Oh, for cin line.chars. Okay. And it's not plural. And we can't implementation of that. Oh, we got to unwrap it. And this will panic, right, if there are no characters to unwrap, but that's fine because we'll panic for the bad character anyway. And if we run out of characters, we pop too much. That means I think that means bad input, but we'll find out. Let's find out. All right, so that checks. Does it run with the sample? 26397. 26397. Checks out. Let's get our puzzle input. Wow. Well, that's not too bad. That'll go pretty quick, right? Day 10. I'm trying to think about part 2, and I can't think of what part 2 is yet. I don't know what part 2 would want of us. Okay, let's close this. Let's move our input into our inputs and change our test to input. See if we're close. 390993. And it is, that's the right answer. Okay, good. That was pretty straightforward. Let's just check in with Clippy and format, and then git status, git add source and inputs, git commit day 10 part 1, and we push it up. I don't have, that's amethyst. I don't need that actually. Smoku, we like Smoku because he had some stuff for us. That's the digger stuff. And this is close. We're almost there. I just like to see my commits. I don't know why. Oh, I don't want to see the thing. I just want to see the list. There. Day 10 part 1. Okay. That was fast. Okay, now day 10 part 2 is now discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. Okay. And so we actually calculated that, right? We have that data. There. We have this in our expect vector, right? To repair the navigation subsystem, you just need to figure out the sequence of closing characters that complete out all the... Okay, and we have that. I think this is just describing how that works. Complete by adding this, complete by adding that, complete by adding that. Okay, so we can do that with our test input. And let's just verify. We should have it in reverse order, so we should just be able to print it out and then show that we can pop it. I'll print it out like that, expect. And then we're going to change this over to our test input so we can compare and see, do we have something close? So it should go brace, brace, square, square, curve, brace, curve, square. Yep, and that works exactly in that right order. This has these four: square, curve, curly, angle. Yep, okay. So we have it. Did you know that autocomplete tools also have contests? Of course they do. The score is determined by considering the completion string character by character. Start with a total score of 0. Then for each character, multiply the total score by 5. Then increase the total score by the point value given for the character. All right, you start with 0, you multiply by 5, and then add 1, 2, 3, or 4 points. All right. I mean, that seems straightforward. So to get the last completion above would be scored as follows. It would be 294. Here's all of them. Autocomplete tools are an odd bunch. The winner is found by sorting all of the scores and then taking the middle score. Okay. There will always be an odd number of scores to consider. In this example, the middle score is this value because there are the same number of scores smaller and larger than it. Find the completion string of each complete line, score the completion strings, and sort the scores. What's the middle score? All right, so we can change score to return a tuple of scores, one for part 1 and one for part 2. Or can we? Because we're going to return something for each one. We want to be able to distinguish between. Yeah, okay, we can do this. So part 1 is this. And we'll just return 0 for the part 2. And then for this one, we'll just generate a score and return 0 and total. All right, and then we'll have to change how we grab this data here. All right, so we need to pop, right? For each character in this array, we're going to pop. So while expect.len is greater than 0. Oh, right, we need total. We start with 0. And we're going to say, yes, while expect.len is greater than 0, we're going to say, we're going to multiply the total by 5. Right? And then we're going to look up the value and then we say total plus equals match of expect.pop.unwrap. And we know that's going to work because we did the len check here. And then we're just going to grab these 4 lines and change them. Like this. And this will just be worth 1 point, 2 points, 3 points, I forgot the comma, and 4 points. Like that. And then this is going to be illegal character again. Like this. See that one lines up. Okay, semicolon there and there. And that's the total. Now, so all we need to do here is instead of folding over this, we can do lines, iter, map. For line, we're going to map it to a score function. And we're going to collect into a vector. And that vector is going to be a result vector, which is a vector of tuples. That should work. And I hit F1 again. Okay, and then for part 1, what we're going to do is we're going to iterate over the results. And we're going to get the tuple, but we only care about the first part of the tuple. So this will be sum is tuple.0. So this should still give us part 1's answer. Right? We should still have 390993, and we didn't. Oh, because we still have the test input. Yeah, so that's our test input value. And this should give us that number. And it panicked. Oops. Multiply with overflow, 36. Really? What is it? How big is it getting? Because I'm doing I-32. Let's just double check. Let's make this an I-64. Now I can't return it. Oops. I-64 there. And now that's going to be bad, so let's change this to I-64. And it doesn't like that because I forgot to change this to I-64. How big are these numbers getting? Alright. Alright, so that time it didn't panic. So the numbers must be getting pretty big. So then part 2 is going to be the middle value of any non-zero score. Right? So we're going to say result iter filter x where x dot 1 is not equal to 0. We're going to collect those into a yeah, this will also be a vec of I-32 and I-64, although we don't need the second part. We can just map it, actually. That way we can just get a vector of I-64s, right? We'll map it x to x dot 1. I'll call it tuple just to be consistent with above. Got to put a dot there and a semicolon there. We got 2 warnings because part 2 isn't being used. And now we say println day 10 part 2 is this, and it's part 2 of part 2.len over 2, and this probably will be a borrow issue thing, over 2 plus 1, right? Because it's an odd number. Dividing by 2 is going to give us 1 less than the middle, and then bumping it up plus 1. Let's just double check that with the test input. Run that. Did we get it? Nope. This says 995444, and this says this. So we got the wrong one. All right, let's print them all out as we calculate them, and then we can see how we're doing the calculation wrong. Maybe the plus 1 was a mistake. Come on, run. There we go. Oh, I didn't sort them. And it is getting this one, so it is getting the wrong one. I would have expected this. This is 5. 5 divided by 2 is 2, plus 1 is 3. Right? The len should be 5. Part 2.len. Let's see if I have that wrong. Part 2 len is 5, so 5 divided by 2 is 2. Oh, and it's already there. Okay, 0, 1, 2. Okay, so the plus 1 is incorrect, but I do need to say part 2, not part 2, so I can say part 2 sort, like that. Okay, run that, and it panics. Method not found in I-32. Oh, part 2 sort. Silly. All right, so we got the right value now. Let's get rid of this println and switch our input back to the actual input. And run this. And we got a big number. And we'll paste it there. And the big number is the right answer. All right, not bad. So where are my personal stats? Right here. 713 to 725. Not bad. Yeah, this one was relatively easy. You can tell based on the rank I got here is 25,000. This is the only one we got under 20,000. But this was also a very easy one to do, right? Compared, like yesterday's was very easy. This one was very easy. We didn't have to learn the Chinese remainder theorem like we did last year. We didn't have to do modulo arithmetic, which is I'm expecting any day now. What else? What else can we do with this? I think this is essentially the whole shebang, right? Is there any cleanup we can do with Clippy? I guess so. An unstable sort would perform faster without any observable difference for this data type. Okay. Oh, just use is empty. Okay, let's do that. I can do sort unstable. I don't mind doing that. And then what's the other one we wanted to do was check to see is while not expect is empty. Like that. And hopefully Clippy's happy with that. Yep, all good. So git add source, git commit day 10 part 2. And we're done. And we can switch over to the roguelike. Huzzah. Actually, before I switch there, I do want to do one more thing because of fun. Yeah, that's the roguelike. Let me pop up a new thing here. What was it? Rust duration. Right. So duration new. There was a way to get instant Rust time instant, and then you can get duration from instant, right? Yeah, now dot elapsed as sec. So what I'm trying to do, I should prefix this with, what I'd like to do is time all these guys. And the way we can do that is making a loop out of this. So I'm going to make a loop out of this. Let days is a vec like that. And we're just going to, instead of calling them, we're just going to make them an array like that. And then we can say for d in days, we can grab a new instant. Let now equals instant now. And I don't need a crate for this. I try to avoid crates in Advent of Code, although I do make an exception for regex. And then we just call D, and then we get the elapsed. And then what we can do is say print when completion time, and I think we can, I don't need nanoseconds, but is there a milliseconds for elapsed time? Well, that's where duration comes in, right? It returns a duration, and duration has, I guess we can do microseconds and then multiply it or divide it by 1,000, right? So what would be a good format? 6.2. And then we say elapsed as micros as F64 divided by 1,000. Right? And that'll give us, for each one, that'll give us a, oh, it didn't like that. Expected slice around an array of 10 elements. Oh, why was it expecting a slice? This should just be a vector of functions, right? Yeah, that's weird. Why did I have to specify that? Huh. Okay, anyway, that worked. Let me run it, and we should see completion times for each one. Yeah. So now we can say, oh, let me put a little ms next to it. that many milliseconds. And let me add a new line to separate each one. Yeah. So now I think I have window over here. I do. I want to compare. Actually, do I have tmux? Because that way I can put two windows side by side. I do. Like that. So now what we can do is say cargo run, and then say cargo run release. Oh. Oh, this is RT. Oops. This is the wrong project. AOC. There we go. Cargo run. I was wondering why I was recompiling. I'll do a cargo run there, and a cargo run release here. Oh, it's too many lines. Oops. And we can compare day 1 and day 2. I mean, sorry, day 1 and day 2. I meant debug versus non-debug. And this is still RT. Aho Korosik. That must... I don't even know what that is. Aho Korosik. We'll look that up while we're waiting. What does this do? A library for finding occurrences of many patterns at once. Oh, a special Aho Korosik algorithm. This is probably the same Aho as the Aho, Sethi, and Ullman compiler's book, right? All right, so you can see the difference now between debug and non-debug, right? This took 4 milliseconds. This took 0.65. What's the longest? Longest over here is this guy, 335 versus 29. And what's the longest on this side is 5.98 versus 56. So I just wanted to do that because fun. And so we can see the completion time for each one. We can actually add them all up, right? Just summing up all the durations, right? If we wanted to do that. I'm not going to do that though. All right. So we're done with day 10. Let's check it in. Oh, hi Tacklebit. It's for string searching. Throw some Rayon in there too. Okay. Maybe next time. All right. Let's push this up to GitHub. Add source. Git commit -m. Show total time taken per day. Git push. All right, so this brings us back to roguelikes. Let me add a stream marker so I can find it next time. Rogue, start, roguelike. There we go, 3407.